Good day, everyone. You are welcome to Royal Learning Channel. My name is Oluwatoyin. Today we are going to discuss about aromatic hydrocarbons. Aromatic hydrocarbons. Then under today's topic, I'm going to discuss about IUPAC nomenclature of aromatic hydrocarbons. Then I'll talk about preparation of aromatic compound. We discuss about IUPAC nomenclature of aromatic hydrocarbons, that is naming of hydrocarbons, aromatic hydrocarbons. Then we discuss about preparation of aromatic compound. Then the word aromatic means that the compounds of aromatic compounds are fragrant or sweet odor. Fragrant, the word aromatic means fragrant odor or sweet odor. So it shows that aromatic compounds are fragrant or sweet odor. So the most common aromatic hydrocarbon is benzene. The most common aromatic hydrocarbon is benzene. While other compounds are derived from benzene by replacing one or more hydrogen atom from benzene structure with an atom, group of atom, or alkyl groups. So when you replace one or more hydrogen atom from benzene with an atom, group of atoms, or an alkyl group, you derive what we call derivatives of benzene. Then aromatic hydrocarbon has a general formula of CN H2N minus 6. So it has a general formula of CN H2N minus 6, whereby N is 6, 7, 8, 9, 10, and so on and so forth. So when you substitute N into this general formula, you get the molecular formula of what? Of benzene. You derive the molecular formula of benzene when 6 is substituted into this general formula. So if I substitute this 6 into this general formula, so that will be 6 times 6 will give me C6. 2 times 6, that is 12. 12 minus 6 will give me 6. So C6H6 is the molecular formula for what? For benzene. So when 6 is substituted into this general formula, you obtain the molecular formula of what? The molecular formula of benzene. When 7 is substituted, when you substitute 7 into this general formula, you are going to obtain this formula, that is C times 7 will give us C7. Then 2 times 7, that is what? 14. Then 14 minus 6, that will be 14 minus 6, that will be 8. So this is the molecular formula for toluene. So toluene is what? Is a derivative of benzene. Then another name for toluene is methylbenzene. Methylbenzene. Then what is methyl? Don't forget that methyl is an alkyl what? Is an alkyl group. Is a member of an alkyl. Methyl, the molecular formula for methyl is CH3. So when you remove one hydrogen atom, don't forget that I said that other compounds of what? Aromatic hydrocarbon are derived from what? From benzene. So when I remove one hydrogen atom from benzene structure, from the molecular formula of benzene, and I replace with CH3, remove one hydrogen atom here, it will give you C6H5. So when C6H5 combine with CH3, it will give you what we call methylbenzene, which is also known as what? Toluene. So CH3 is what? Is methyl, while C6H5 is derived from what? From benzene. That is why they call them what? Derivative of benzene. So add 6 carbon atom plus 1 carbon atom here will give you 7 carbon atoms. So 5 hydrogen plus 3 hydrogen will give you 8 hydrogen. So this is the molecular formula for toluene, or you write it in this way. So that's why they call it what? Methylbenzene. So when you replace N when you replace your N with 8, it will give you the molecular formula for xylene. 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 Xylene is also known as 1,2-dimethyl benzene. So xylene is 1,2-dimethyl-benzene. So let me replace my N with what? With 8 to get the molecular formula for xylene. So C times 8 will give you C8. 2 times 8. 2 times 8 is what? Is 16. Then 16 minus 6 will give me what? Will give me 10. Then if I want to draw it in form of structure, I will first remove the molecular formula for benzene, then remove one hydrogen atom and replace with 2 methyl. Methyl is CH3 in 2 places. Like the structural formula for benzene is in this form. So if you attach one methyl, which is CH3, then you attach another methyl, CH3, it shows that you have removed 2 hydrogen atoms from the molecular formula of what? Of benzene. So remove 2 hydrogen atoms from the molecular formula of benzene will give you C6H4. Then the CH3A and CH3A they've occupied the position of what? Of the 2 hydrogen atoms that you remove from the molecular formula of benzene. Then put this CH3 in 2 places in bracket. So CH3 in bracket 2. So you can write the molecular formula for what? For xylene or 1,2-dimethylbenzene in this way. So this is the molecular formula either in this way or you write it in this way. This is the molecular formula for what? Xylene or 1,2-dimethylbenzene. So we also have another compounds of hydrocarbon, that is the derivatives of aromatic hydrocarbon, apart from toluene, apart from xylene, and apart from benzene itself. So we also have other compounds that we can derive from benzene structure, from the molecular formula of benzene. So another one is benzoic. The word oic is derived from archanoic. Another one is benzoic. So this oic is derived from the what? From archanoic. The oic is derived from archanoic. So the oic, the functional group of archanoic is COOH. So when you replace one hydrogen atom from the molecular formula of benzene is C6H6. So when you replace one hydrogen atom from here, when you substitute one hydrogen atom from this benzene with oil, it will give you what we call benzoic. So that will be C6H5. Remove one hydrogen atom and replace with what? COOH, which is oic. So this is the molecular formula for benzoic. Benzoic is also what? Is a derivative of benzene. We also have aminobenzene. The word amino is derived from the amino group. That's NH2. So when you remove one hydrogen atom from benzene and you replace with NH2, remove one hydrogen atom, that will be C6H5. Then replace with amino, that's NH2. So this is what we call aminobenzene or aniline. So those are the words. We have other derivatives of benzene. So let's move to IUPAC nomenclature of benzene. Now, before I move to IUPAC nomenclature of benzene, benzene has 2 possible structure according to August Kekule. Benzene has 2 possible structure according to August Kekule. So those 2 structure, they only differ in the position of the double bond. Those 2 structure differ in the position of the what? In the position of the double bond. structure can be in this form. The first structure of benzene. Don't forget that the molecular formula is C6H6. Now, we have 6 carbon atoms because aromatic hydrocarbon, that is benzene, it is an unsaturated hydrocarbon due to the presence of what? Of double bond. Due to the presence of double bond in its structure, it is unsaturated. So, we have 6 carbon atoms now. 1, 2, 3, 4, 5, 6. Then the structure of benzene is hexagonal in shape. It is hexagonal in shape. So, add one bond to complete what? 4 chemical bond that must surround what? Each carbon atom. You add one bond. Don't forget, in organic chemistry, each carbon atom must be surrounded with 4 chemical bonds. Now, 1, 2, 3, 4 to complete it. 1, 2, 3, 4. The next one, 1, 2, 3, 4. You have to add one there. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So then you what? You bring in what? Your hydrogen atoms. So this is the structure of what? Of benzene. This is the structure of benzene according to what? Kekule. According to August Kekule. Then the structure can also be in this form. When you close what? All these hydrogen atom or the chain or the bond, you are going to have something like this. Draw your 6 what? Hexagonal shape. Then your double bond here, your double bond here, it will alternate. Your double bond here, you jump this one, double bond here, you jump this one, then you double this place. So this is another structure of what? Benzene, according to what? August Kekule. So when you close it like this, you don't put what? Hydrogen atoms. You don't add those hydrogen atoms. Then another one, the second one is the position. The double bond is at this side. Then it is possible to start your double bond. It is possible to start putting double bond at the what? At the left hand side. At the left hand side. So if I put my double bond at the left hand side, if I start putting my double bond at the left hand side, the structure will be in this form. So instead of starting from this side, you can start your what? Double bond from this side, then you alternate it. You alternate it. Double bond there, you jump here. Double bond here, you jump here, then you put your double bond here. So these are the possible what? The possible 2 structures of what? Of benzene. So the only differences between them is the position of the what? The position of the double bond according to what? August Kekule. All these structure are according to what? August Kekule. Then the localization of the what? Of the double bond from this ring. The localization of the double bond. Don't forget that our double bond, the double bond is also known as what? Pi bond. So the pi electron, so when the double bond, that is this pi electron, when it moves around all the 6 carbon atom, it will form a ring. It will form a ring. So when this double bond, the double bond here now travel around the what? Travel around the 6 carbon atoms. Don't forget that there's 1 carbon atom here, one carbon here, one carbon here, one carbon here. So by the time your double bonds move round, by the time your double bonds travel around the what? The 6 carbon atom, you are going to have a closed ring called resonance structure. So you are going to have this closed ring. So the double bond will close to form what? A ring inside. So this structure is called what? Resonance structure. It is called resonance structure. So you can have the structure of your benzene either in this form or in this form. This is the resonance. This is the structure according to August Kekule. And why this structure is called what? Resonance structure, when the double bond in the ring are delocalized. So resonance structure. Then let's move to naming of aromatic hydrocarbon. Naming of aromatic hydrocarbon. Naming of aromatic hydrocarbon. So naming of aromatic hydrocarbon. Let's look at this structure. So this is the structure of what? Of benzene. Either in what? In resonance structure or in Kekule structure. So this is the structure of benzene. So when you attach COOH to this structure, when you attach COOH, you call it benzoic. Benzoic. The COOH is the oic, that is the carboxyl group, the functional group of alkanoic. The oic together with benzene will give us benzoic. 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 Then when you attach an alkyl group, when you attach one alkyl group to the structure, if I attach CH3, this is methyl, then and benzene. So what you call it? CH3 is methyl. You call it methyl what? Benzene. Benzene. Methylbenzene. So the molecular formula for this structure will now be C6H5. Don't forget that this benzene itself is C6H6. So this CH3 has taken place, has occupied the position of what? Of hydrogen atom. One hydrogen atom. So one hydrogen atom will be removed and CH3 will come in. So to give you C6H5CH3, which is the molecular formula for what? For methylbenzene. Methylbenzene. So let's look at another structure. So this time around, we have two different substituents. We have CH3, we have Cl. CH3 is a substituent. Why? Because it's attached to the structure of what? Of benzene. Chlorine is also what? Is a substituent because it's attached to the structure of benzene. Then this is a mixture of organic and inorganic substituent. CH3 is organic, while Cl is what? Is an inorganic substituent. So when you have a mixture of organic and inorganic substituent, you name what? Inorganic substituent before your organic substituent. Then this is the first carbon atom. This is the position for the first carbon atom. So this methyl CH3 is on the first carbon atom. Then this is the position for the second carbon atom. While this is the position for the third carbon atom. So 1, 2, 3, 4, 5, 6. So the chlorine is on the third carbon atom. And in organic chemistry, in naming of organic compound, chlorine will sound what? Chloro. So you call it 3-chloro. 3-chloro. Then the methyl is on the first carbon atom. So you call it 1-methyl. 1-methyl. Then your root hydrocarbon is the structure of what? Of benzene. So 1-methyl what? Benzene. So the name of this structure is 3-chloro 1-methyl what? 1-methyl benzene. 3-chloro 1-methyl benzene. So let's look at another structure. Let's look at another structure. Then we have two different substituents, but the two substituents are what? Are organic. The two substituents are organic. So if I count from, you can name from this side, from the left hand side, you can name from the right hand side. So if I name from the right hand side, 1, 2, 3, 4, 5, my methyl will be on the fifth carbon atom. My methyl will be on the fifth carbon atom. If I name from this side 1, 2, 3, my methyl will be on the what? On the third carbon atom. So the best position to name is from the left hand side. 1, 2, 3. So we have two different what substituents now, and both substituents are what? Are organic substituents. C2H5 is called what? Is called ethyl, while CH3 is called what? Methyl. So when we have different substituents, you must name them what? Alphabetically. So therefore ethyl will come before what? Methyl. So your ethyl is on the first carbon atom, you call it 1 ethyl, comma, then the methyl is on the third carbon atom, that will be 3 methyl, then the structure is what? Is benzene. The structure is benzene. So that is 1 ethyl, 3 methyl benzene. 1 ethyl, 3 methyl benzene. Then we also have another structure, that is when two structures of benzene are joined together. When two structures of benzene are joined together. When two structures of benzene are joined together, a compound called naphthalene is formed. A compound called naphthalene is formed. So we have two structures of benzene. Then you put your double bond. One, you alternate it. Another double bond here, one here. So by the time you want to put another double bond, you start from, since there is no double bond there, you put one here. No, let's start from this side. One, you alternate this, one, then there will be one double bond there. So you don't put double bond there, because this double bond will affect what we're having here. Will affect the number of bond that surrounded what? This carbon atom that is here. There's one carbon atom here. So you omit this one, then you move to this place, double bond, you alternate it again, then you move this double, you put another double bond here. So this structure is the structure of naphthalene. Naphthalene. So when three structures of benzene are joined together, you produce what we call anthracene. Anthracene. So this is another one. Three structures of benzene joined together. So double bond here. You omit this one, double bond here, then double bond here. So you don't put double bond there, double bond here. You omit this one, double bond here. Then double bond here, double bond here. So this is the structure of anthracene. Anthracene. Then anthracene is also what? Is a derivative of benzene. Anthracene is a derivative of benzene. So let's finally move to preparation of benzene. Preparation of benzene. What method of preparing benzene? Method of preparation of benzene. So the first method of preparing benzene is by heating benzoic acid. Heating benzoic acid, heating benzoic acid with quicklime. Quicklime. Then what is quicklime? That is calcium oxide. Quicklime is calcium oxide. So reaction between benzoic acid and quicklime will give us benzene. So let's see chemical reaction between benzoic acid and quicklime. Benzoic acid is when the oil, that is the functional group of alkanoic, attached to benzene ring. This is the benzene ring. Then the oil, which is the functional group of alkanoid, COOH, attached to what? To the structure of what? Of benzene. To the structure of benzene. So plus calcium oxide. Calcium oxide. CaO. So reaction between benzoic and calcium oxide will give us benzene. So what are we going to do? You decompose this COOH, then you remove CO2 from COOH, then the hydrogen will come in. Let me first use molecular formula to explain. I'm going to use molecular formula first to explain. So what will be the molecular formula? That will be C6H5. Instead of H6 from benzene, we have removed one hydrogen atom from benzene and replaced with alkanoic, that is the oil, the carboxylic group, COOH. Then plus CaO. Then C6H5COOH is the what? Is the molecular formula. This is the structure, while this one is the what? Is the molecular formula. So by the time calcium reacts with what? With benzoic acid, that is C6H5COOH, it will remove what? CO2. So remove CO2 from this structure, that is carbon and these two oxygen will go. Carbon and these two oxygen will go. So by the time you remove carbon and two oxygen, then hydrogen will come in to give you what? C6H6. So remove COO. Then COO will now combine with what? With CaO to give us Ca, then followed by one carbon atom, C, then two oxygen here plus one oxygen here will give us O3. So it will give us C6H6CaCO3. So that is the C6 we have produced what? We have prepared C6H6, which is what? Benzene. So it can also be written in this form. So the benzene structure will now be only this structure. Then plus what? CaCO3. So this is the first method of preparing what? Preparing benzene. The first method of preparing benzene. Then number two. So number two is by heating sodium benzoate. By heating sodium benzoate with soda lime. Sodium benzoate with soda lime. Then what is the formula for soda lime? That's sodium hydroxide. So heating sodium benzoate with soda lime. So let's look at chemical reaction between sodium benzoate and soda lime. The sodium benzoate, the benzoate is from alkanoate. So it shows that we are going to have a benzene ring. The alkanate is RCOOR. Then the R at the back will be replaced with sodium. So that will be RCOONA. Then the R here will be replaced with what? Benzene. Then for this COOH to attach to benzene, there will be removal of one hydrogen atom. From benzene. So benzene will now what? The structure from benzene will be C6H5. Then you attach COONA. You attach COOH. So this is sodium benzoate. So reaction between sodium benzoate, which is C6H5 COONA. So reaction between sodium benzoate and soda lime, that is NaOH, will give us benzene. So let's see how we are going to form our products. Now, the sodium benzoate will decompose to C6H5, then COONA. Then reaction between soda lime and sodium benzoate will release hydrogen. So the hydrogen here will combine with C6H5 to give us C6H6. That is hydrogen plus C6H5 will give us C6H6. Then COON8, the OH, will combine with NaO to give us Na. We have one sodium here, that is 2 sodium. That's Na2. Then one carbon atom. Then how many oxygen? 2 oxygen here plus 1 oxygen here will give us 3 oxygen to produce sodium triazocarbonate 4. Then another method of preparing benzene is by reaction between hydroxybenzene, phenol, and zinc dust. Reaction between hydroxybenzene or phenol. Hydroxybenzene is also known as phenol. The third method, heating hydroxybenzene or phenol with zinc dust. Then what is hydroxy? Hydroxy means OH. Then an hydroxy group we attach to the structure of benzene to give us hydroxybenzene. Then the structure of benzene plus what? An hydroxy group, OH. Or you do it in this form. The structure of the molecular formula, that will be C6H5. Because you have removed one hydrogen atom, then OH will come in. Then plus what? Plus zinc dust. That's Zn. Or in this way, plus Zn. So let me use the molecular formula to explain. So there will be decomposition. This one will release what? Hydrogen. It will release oxygen. Then oxygen will combine with what? With zinc to give us zinc oxide. Then hydrogen will combine with C6H5 to give us C6H6. So that is C6H5 plus hydrogen will give us C6H6. Then oxygen will combine with zinc to give us zinc oxide. That is the third method of preparing benzene. And lastly, polymerization of ethyne. Will give us benzene. Polymerization of ethyne will give us benzene. Of ethyne. So polymerization of ethynes means when more than one molecule of what of ethyne join or link together. So when three molecules of ethyne is C2H2. Ethyne is C2H2. So when three molecules of ethyne join together, it will give us C6. 3 times 2 will give us C6. Then 3 times 2 hydrogen will give us H6 to produce the what? The molecular formula of benzene. To produce the molecular formula of benzene. So this is where we are going to stop today. Remember to subscribe to Royal Learning Channel. Share this video with your friend and comment. See you in my next class. In my next video, I'm going to explain chemical properties of benzene and uses of benzene. See you in my next video. Bye.